Hello everybody. I am Hélène Gonin, the event manager at Shell Group. Welcome to this new Analyst Thursday webinar about semiconductor test. Today, I will be joined by John West, the Senior Division Director in the Semiconductor Subsystem and Test activity at Shell Intelligence. John will answer a big question: how next generation chip for high performance computing will drive innovation in semiconductor test. I think we are ready now. So John, the floor is yours.
Thank you for the introduction, Helen. So today the topic is, how will the next generation chips for high performance computing drive innovation in semiconductor test? So first, before I start to talk about that, I will provide some context by talking about the overall market for test equipment and test consumables, and review the challenges and the changes in the cost of test, which are driven by test complexity. And then I will start to talk in more detail about testing high performance computing chips in particular, and as part of the conclusion, talk about how the complexity of tests will change going forwards and what that means for the suppliers in the test community. So first of all, we all have a service which covers the complete test ecosystem. We have 4 modules, one for Procards, another for test and burn-in sockets, test interface boards, and finally we have a new module which we introduced earlier this year, which is ATE probers and handlers. So we cover all of the test equipment and consumables. We track over 197 vendors, over 38 unique segments, and 8 applications. So this chart really is showing the evolution of the test market for test equipment and consumables by application. The applications that we cover, or we break it down into, are DRAM and non-volatile memory for memory applications. And then in the non-memory space, we cover sensors, power, RF, high-performance computing, MEMS, and other logic. So this chart really shows you how over the last 5 years, really from 2017 to 2022, the industry has grown significantly quickly at a CAGR of 11.8% a year. This year in 2023, we're seeing a bit of a downturn driven primarily by the memory market, and also it's particularly badly affected the ATE market and also probe card market. So we expect to see a decline of 14% this year. But the overall outlook is for the industry to continue growing at a 6.2% CAGR over the next 5 years to reach a value of nearly $20 billion in 2028. So I think it's also helpful just to take a long-term view. So this chart shows the amount of money being spent on test equipment. So that's testers, probers, handlers. You can characterize this really from 2000 to 2015. The blue line, very volatile, trending downwards. So the industry was actually spending less money on equipment year over year for about 15 years. A lot of this was driven by the increased use of OSATs, increased parallelism in test, which was significantly reducing the amount of money that was being spent on testing devices. But we've really seen since 2016, these efficiencies are starting to be offset now by increased test complexity. So we're seeing that test times are increasing, the physical requirements for testing some of these devices, like higher pin counts, higher pin densities, thermal challenges as well, are actually driving costs of equipment and consumables back up again. And we see that really from 2016 to 2028 that the test equipment industry is actually growing more in line with the growth of the semiconductor industry overall. The orange line really shows a 5-year rolling average to take out some of those, the volatility in the curve. And again, that shows clearly from, say, 2005 to 2014, 15, the amount of money the industry was spending year over year was reducing on test equipment, but you can see that it's been growing steadily since 2017 for multiple reasons. This is the situation for test consumables. So this is probe cards, test and burn-in sockets, and interface boards. A little bit less volatile. Clearly, there was a few downturns here. There's the one in 2008 and 2009 financial crisis that was outside the industry's control. I think the downturn that we're seeing in 2023 is two things, really. One is memory crash is really driving down test equipment and probe card demand for memory devices. But I think also there was oversupply in 2022. So it's a bit of a reaction that we would expect the market to start growing again by 2024. This brings us around to the cost of tests. Combining equipment and consumables, the industry historically has been spending consistently around about 2.5% of its revenues on testing devices. That's the best way on test hardware. Last few years, we've seen this increase up to 3%. A lot of that was driven by system or the introduction of system level test. So this was an additional test for, again, particularly for high performance computing devices or very complex devices. So that was really a cost adder. It didn't remove cost of test elsewhere, because those devices still had to be tested on a wafer. They had to be tested at package level. They had to be burned in, and in addition, they were tested at the system level. So this increased the percentage up to 3%. But we still think that the industry will really try to push these costs back down to that 2.5% target level. That's going to be quite a challenge, really, because there are some very strong forces in play that are going to be trying to push this cost of test curve back up to 3% or even higher. We're seeing that device complexity is just growing, and a function of that is longer test times. Devices have much more functionality that has to be tested, so test times are increasing. We're finding the physical attributes of these devices are increasing. So higher pin densities, higher pin counts, higher powers, higher currents, lower powers, higher frequencies. On multiple fronts, it's becoming much harder to test these devices. And there's also an increased amount of testing going at the wafer level. So this is both just regular probing of wafers, so we get the known good die. But actually, there's also another drive to get more of the wafer level burn-in done at wafer level, again, to try and save some costs of package test and burn-in test later. And of course, now we're starting to see chiplets, the introduction of chiplets. Again, at the moment, it's not quite clear, but at the moment, it does look like that's going to be driving a higher demand for higher specification sockets and higher specification probe cards with more probe card touchdowns. But on the other side, we're seeing introduction of hybrid bonding for some advanced packaging is actually removing some of the tests from wafer level. It's not ideal. They would like to test the wafers at wafer level, but they're finding that the actual process of touching the wafer with a probe card is actually reducing significantly the yields of the hybrid bonds when it comes to packaging the devices. So some chip makers, for the moment, are skipping wafer test when it involves hybrid bonding techniques. But overall, you can see cost of test, it looks like it's under control and it's manageable. But this is an overall aggregate number. What it doesn't really show is that for particular devices or specific devices, the cost of test are actually going up, and it's becoming quite a big problem for the industry to manage. So here's a quick review of some of the challenges of testing devices, both from the design, designing the test solution, and also manufacturing the equipment and consumables that are required to test those devices. So this chart or this graphic was presented by Teradyne at SW Test in 2023. So I thank Eric Shoemaker and Steve Ledford for allowing us to use this. I think it's quite self-explanatory. Chips become more complex. We have to manage higher speeds, higher frequencies, more pins, more components, and we have to also run more simulations to try and figure out what that test solution would look like. But then on the manufacturing side, we're finding that we're finding larger device interface boards with more layers, with smaller pitches. We're seeing the same thing for probe cards, higher pin counts, smaller pitches. And again, we're also trying to see now that really the quality of the test really depends on the connection to the device being tested or the wafer being tested. So we're trying to find a solution which makes sure we have the best possible electrical contact with the device we're testing, and also try to bring more test functionality closer to the device. And again, that's driving much more complexity into the PCB market. So whether that's probe card PCBs, burn-in PCBs, and also load boards. There's a much more complex complexity of structure and design for those products. So this brings us on to testing high-performance computing. So on every one of those factors, in terms of complexity and manufacturing complexity as well, this is really driving up the cost of testing high-performance computing chips. So the blue line here on this chart shows the total amount of money the industry is spending on test equipment and consumables for testing these devices. It was around about $1.6 billion was being spent on in 2016. Last year, it more than doubled to $3.25 billion, a bit of a downturn this year. But essentially, we're seeing a long-term average growth rate of above 10% over this period. And I think it's important to give some context. So this is one of the largest segments of applications for semiconductor test at the moment, and its share of the total test cost is actually increasing. So last year it represented 17% of total semiconductor test costs, and we would expect this by 2028 to account for over 22% of semiconductor test costs. And this is quite a conservative forecast, because we're already factoring into our forecast that the suppliers of equipment and consumables will be able to find those solutions to drive down the test cost. And also we assume that the chip makers will find ways to optimize their test solutions for testing these types of devices. But if they can't do that, then this forecast could be significantly higher. Another way to look at this is really to look at the cost per device tested, and also how much money the chip makers are spending on testing these devices as a percentage of their total revenues. So let's start with the orange line first. So that's the cost in cents per device tested. Back in 2016, they were spending 80 cents on testing a device. Last year, it got to almost $1.50 last year. So that's been a 10% growth CAGR year over year over the last 5 years in the cost of test per device. Not really such a problem for the moment, because these devices are incredibly expensive. Some of these devices are selling for hundreds of dollars, thousands of dollars, or in the case of some of NVIDIA's chips, tens of thousands of dollars. So the $1.50 cost of test probably doesn't seem like a problem, but I think you can see that if it continues to grow at this rate, then it would be a problem within the next 5 years. We would again expect these cost per device tested to get to a target level of around about $1.4 or $1.5 going forwards, but that does depend on solutions that are not yet known. The blue line shows the amount of money the chip makers are spending as a percentage of their total revenues. So historically, from 2016 to 2021, the blue line there is $1.2. No, sorry, not $1.2. It's between 3 and 3.5% of their total revenues is being spent on testing the devices. That jumped up to 4% last year. We would again being very aggressive with our forecast, assuming that the chip makers will be able to drive some of those costs back down again, and get that back down to that 2.5 to 3% target range if they can do. But this is being very conservative with our forecast. There's a lot of work to be done to solve the problems, to try and keep these costs under control. So looking at it from a Procard perspective, suppliers of Procards have been big winners when it comes to testing chips for high performance computing. Back in 2017, the Procard suppliers were selling $46 million, which is around about 3% of the total Procard market back then. And now there's a whopping $204 million. That's 8% of their total revenues are now going to probing high performance computing chips. And that's a 34.4% CAGR over the last 5 years. So really, the amount of money that's being spent on Procards has increased 4 times in the last 5 years, and most of that's been driven by actually the volumes of chips that are being produced, but also higher pin counts, which lead to more expensive probe cards. The ATE probe handler and test handler companies, they've had quite a nice bump or a boost from this. The market for them has doubled in the last 5 years, gone from $1.28 billion up to $2.29 billion last year. Most of that's been driven by longer test times and higher test specifications, more expensive equipment required to test high performance computing devices. Then from a test socket and a burn-in socket perspective, grown from $265 million up to $468 million last year. It's a 9% CAGR, which again is outgrowing the overall market for test and burn-in sockets. I think high performance computing is going to be a big driver for test sockets. So some of these sockets can have over 9,000 pins. And that means some of these sockets are selling between $10,000 and $20,000 each. And the volumes, especially for graphics processors now, as it's starting to come up. So companies like NVIDIA, when they place an order for test sockets, they could order over 1,000 at one time, which again is very unusual for the industry to be ordering such large volumes for any particular application. And then finally, we have test interface boards for high performance computing. Less spectacular growth, around 4.8% CAGR over the last 5 years, from about $225 million to $284 million last year. Again, to put this in context, the market for interface boards has always typically would normally grow between 1% and 2% year over year. So this is quite strong growth for them, and that has been driven again primarily by high performance computing, which means larger PCBs with more and more layers required. So we're hearing of some interface boards needing more than 80 layers to to find the solution for testing high-performance computing chips. And even burning boards are becoming much more complex. So in the past, burning boards could be typically made by any PCB manufacturer, but we've seen in the last 5 years that for leading edge applications, only specialist PCB suppliers are able to develop, design, and manufacture those boards. And again, they have many more layers than they would typically have had in the past. So really to try and summarize some of the technical challenges that we have moving forward. This is a chart again presented by Teradyne at SW Testing earlier this year. It's looking at pin densities, signals, the power levels, and the thermal challenges that the industry has today, and is just about managing to deliver the solutions for that are required for today. But if we extrapolate what happened in the past to today to the future, 2030, if we extrapolate those changes, by 2030, which is in 7 years' time, this shows some of the requirements that we could potentially be looking at having to solve in the next 7 years to deliver the solutions that the industry requires. So in all of these cases, we're looking at a doubling or even a quadrupling of requirements. And solutions to these are not known, or at least not even sure if they're even possible at the moment. So there's a lot of work needs to be done to try and hit these targets. Now, I don't expect that we would hit all of these targets, but I think we can see that this is quite a rich and dynamic market, which is going to require a lot of innovation to solve, if not all of these, at least solve some of these, or at least go some of the way to solving the problems. And it does require everybody in the test community to work together to solve some of these. And we're already seeing some of this right now with the test equipment companies working closer with the interface board suppliers, with the probe card companies and the socket suppliers to try and find solutions which can optimize the test solution, which will actually work today. But I can see already that over the next 5-6 years, a lot of innovation is going to be required to solve these problems. And of course, this innovation is going to cost a lot of money, take a lot of time to solve. So really, in conclusion, I think it's clear suppliers of test equipment and consumables will have a lot of work to do to find these solutions, both from a designing the test solution, but also from a manufacturing complexity perspective. This will require a lot of R&D to solve these challenges. Maybe more collaboration between chip makers, equipment companies, and the consumable suppliers. And they have to be, these challenges have to be solved, because as a community, all of us are depending on reliable chips. We expect our chips to work, and we depend on them to work. And the fact that in today's society, we very rarely find chips that fail. I mean, it's quite a rare event to find chips failing in the field, and we would expect to see that again going forward. So, these solutions have to be found. And I think it's also important to state that the semiconductor test industry has always been very innovative. We've seen that in the way that the cost of tests have been dropping from 2000, say, to 2016. A lot of that was to do with innovations. I think since 2016, it's become more difficult. But again, innovations have managed to at least keep the cost of test to a manageable level. And again, we'll assume that the industry will step up and deliver those innovations that will be required over the next 5 years. So in summary, I'd like to say this is a great time to be part of the semiconductor test community. A lot of challenges and a lot of interesting work to do. So with that, I will hand it back to Hélène.
Okay, thank you, John. Thank you for your presentation. I just wanted to add that the new quarter, the new update of the semiconductor test equipment market monitor is available. So if you have any question about it, we will be pleased to answer you. Don't hesitate to contact us. The webinar is now ending, so thank you very much for your presentation. I'd like to remind you that the replay and the presentation will be available on our website tomorrow. You can watch it again, and we will be pleased to answer your question if you have some more after the webinar. Next week, don't miss the opportunity to attend our product presentation during Semicon West and meet our Analyst team in our dedicated meeting room. We will spend time with you on July 12th to share insight and trends our experts are seeing in semiconductor fab equipment, fab systems, wafer data, and semiconductor advanced packaging. We're looking forward to seeing you there. Let me remind you that the next date for the Analyst Thursday webinar will be on September 7th about automotive electrification. You can already register on our website and join the webinar in September. It's now time to say goodbye. Thank you again for your attendance and see you soon.